Hello students, this is Usha from G.K.Jain High Secondary School. Today we are going to see the electromagnetic waves part 3 in 12th standard physics. In this we are going to see about the electromagnetic wave spectrum and then its types. Produced from hot bodies and also when the molecule undergo radiational and vibrational transitions. The wavelength ranges is 8 into 10 power minus 7 meter to 5 into 10 power minus 3 meter. And frequency ranges are 4 into 10 power 14 Hz to 6 into 10 power 10 Hz. It produces electrical energy to satellite by means of solar cells. It is used to produce dehydrated fruit in greenhouse to keep the plants warm, heat therapy for muscular pain or sprain, TV remote as a signal carrier to look through haze, fog or mist, and it is used in night vision and infrared photography. Next we'll go into the visible light. It is produced by incandescent bodies and also it is radiated by excited atomine gases. The wavelength ranges 4 into 10 power minus 7 meter to 7 into 10 power minus 7 meter. And frequency ranges are 7 into 10 power 14 Hz to 4 into 10 power 14 Hz. It obeys the law of reflection, refraction, interference, diffraction, polarization, photoelectric effect and photographic action. It can be used to study the structure of molecules, arrangement of electrons in external shells of atoms and sensation to our eyes. Next is ultraviolet radiation. It is produced by sun, arc and ionized gases. The wavelength ranges 6 into 10 power minus 10 meters to 4 into 10 power minus 7 meter. And frequency ranges are 5 into 10 power minus 17 Hz to 7 into 10 power 14 Hz. It has less penetrating power. It can be absorbed by atmospheric ozone and harmful to human body. It is used to destroy bacteria, sterilizing the surgical instrument, burglar alarm, detect the invisible writing, fingerprints, and also in the study of molecular structure. Next, X-rays. It is produced when there is a sudden declaration of high-speed electron at high atomic number target and also by electronic transition among the innermost orbit of atoms. Its wavelength range 10 power minus 13 meter to 10 power minus 8 meter and frequency range are 3 into 10 power 21 Hz to 1 into 10 power 16 Hz. X-rays have more penetrating power than ultraviolet radiation. X-rays are used extremely in studying structure of inner atomic electronic shells and crystal structure. It is used in detecting fractures, diseased organs, formation of bones and stones, observing the progress of healing bones. Further, in a finished metal product, it is used to detect faults, cracks, flaws and holes. Next is gamma rays. It is produced by transition of atomic nuclei and decay of certain elementary particles. They produce chemical reaction on photographic plates, fluorescence, ionization, diffraction. The wavelength ranges 1 into 10 power minus 14 meter to 1 into 10 power minus 10 meter. And frequency range are 3 into 10 power 22 Hz to 3 into 10 power 18 Hz. Gamma rays have high penetrating power than X-rays and ultraviolet radiation. It has no charge but harmful to human body. Gamma rays provide information about the structure of atomic nuclei. It is used in radiotherapy for the treatment of cancer and tumor, in food industry to kill pathogenic microorganisms. Next we go into the types of spectrum. There are two types of spectrum. One is absorption spectrum, another one is emission spectrum. So under absorption spectrum, it is being divided into two. One is continuous absorption spectrum, another is line absorption spectrum, band absorption spectrum. In that we are going to learn about the Fraunhofer lines. In emission spectrum, there are three: band emission spectrum, continuous emission spectrum and line emission spectrum. When an object burns, it emits colors. That is, it emits electromagnetic radiation which depends on temperature. If the body becomes hot, then it glows in red color. If further temperature increases, it becomes reddish orange color and become white when it is hottest. So, we will learn now the emission spectra. When the spectrum of self-luminous source is taken, we get emission spectrum. Each source has its own characteristics emission spectrum. The emission spectrum can be divided into three types: One is continuous emission spectra or continuous spectra. The diagram shown over here, continuously the pattern of colors will be displayed. If the light from incandescent lamp is allowed to pass through prism, it's split into 7 colors that we can see through spectroscope. Thus, it consists of wavelength containing all the visible colors ranging from violet to red. Example is shown in the diagram. Spectrum obtained from carbon arc, incandescent solid, liquid gives continuous spectra. Next is line emission spectra or line spectrum. Suppose light from hot gas is allowed to pass through prism, line spectrum is observed. Line spectra are also known as discontinuous spectra. The diagram shows here discontinuously you are able to see the colors. The line spectra are sharp line of definite wavelength or frequencies. Such spectra arise due to excited atom of elements. These lines are the characteristics of the elements, which means it is different for different elements. Example, spectra of atomic hydrogen, helium, etc. Band emission spectrum or band spectrum. Band spectrum consists of several number of very closely spaced spectral lines which overlap together forming specific band which are separated by dark spaces known as band spectrum. This spectrum has a sharp edge at one end and faded out at the other end. Such spectra arise when the molecules are excited. Band spectrum is the characteristics of the molecule. Hence, the structure of the molecule can be studied using their band spectra. Example, spectra of hydrogen gas, ammonia gas in the discharge tube, etc. Next, we'll go to absorption spectra. When light is allowed to pass through a medium or an observing substance, then the spectrum obtained is known as absorption spectra. It is the characteristics of absorption spectra. Absorption spectra is classified into 3 types. One is continuous absorption spectrum, line absorption spectrum, and band absorption spectrum. First, we'll see about the continuous absorption spectrum. When the light is passed through a medium, it is dispersed by the prism, we get continuous absorption spectra. For instance, when we pass white light through a blue glass plate, it absorbs everything except blue. This is an example of continuous absorption spectrum. Next is line absorption spectrum. When light from the incandescent lamp is passed through cold glass, that is any of the medium, the spectrum obtained through the dispersion due to prism is line absorption spectrum. Similarly, if the light from the carbon arc is made to pass through sodium vapor, a continuous spectrum of carbon arc with 2 dark lines in the yellow region of sodium vapor is obtained. Next is band absorption spectrum. When the white light is passed through the iodine vapor, dark bands on continuous bright background is obtained. You can see in the diagram. When this type of band is also obtained when white light is passed through dilute solution of blood or chlorophyll or through certain solution of organic and inorganic compounds. Next is Fraunhofer lines. The diagram shows there when the spectrum obtained from the sun is examined. It consists of large number of dark lines, that is line absorption spectrum. These dark lines in the solar spectrum are known as Fraunhofer lines. The absorption spectra for various material are compared with the Fraunhofer lines in the solar spectrum, which helps in identifying elements present in the sun's atmosphere. Hi students, you all have learned about the types of spectrum, that is 2 types, emission and absorption spectrum. Thank you. Once again, we'll meet you in the next video.